Okay, welcome back. This is Mr. Steele once again, and this time I'm taking you through another one of the standard quiz questions on the Calculus A/B standard quiz at Franklin High School. This time taking you through one that people have been doing better on, especially, well, at least jumping from week 1 to week 2, since that's when I'm making the video. But at the same time, it's one that's really important to be able to handle as we go deeper into Chapter 2 about derivatives, because eventually you will, probably about Thursday or Friday, actually see where these problems come from that have been littering your standard quizzes in honors, pre-cal, and calculus the last 2 years. So finally you'll have a real firm purpose. At the same time, we need to be able to do this, and I get a lot of questions about this each week. So what I figured would be good is I'm going to go ahead and go through one that's kind of the easy one, where the coefficient or the exponents are all really nice, and I'll go ahead and work my way through that and explain all the steps. Then we'll do one with the fractions in front, because that does tend to be where people get thrown off. So first of all, what we have to think about is what this question is asking us to do. This question is asking us to factor and simplify. Basically, that translates to GCF and CLT. Those two acronyms, greatest common factor and then combined like terms, are all we're really doing when we do a problem like this. And in fact, I've shown in class when I've worked with people basically that this is really just GCF factoring when we start off with. There's always a pattern that works out here, as you'll see. Why? Because it comes from the chain rule. But when we start off with, basically we just have to start by recognizing that fact and thinking about, okay, what is it that comes out? Like, what would be a GCF for this guy? So my strategy for doing that is I basically create a little t. And I create that t working in tandem with what I will call, technically speaking, the answer line. So the answer line is the place where you write your answer on the standard quiz. Basically, every time you pull out a GCF factor, since we're trying to factor this thing, I'm going to write that factor over here. Then I'll in effect divide it out from the problem because I've already factored it out here. It's just an easy way to stay organized when I do the problem. So for example, what I do is I basically look for each factor. And I look at, say, the 3x minus 2 and I ask myself, okay, I've got 3x minus 2 to the 4th, 3x minus 2 to the 5th. I want to pull out the greatest common factor that I can get from both of these terms. It's got to be the one that has the smaller exponent. So as soon as I find that smaller exponent, I go, okay, I'm going to pull out a GCF of 3x minus 2 to the 4th power. 3x minus 2 to the 4th power. And down here, I'm going to write 3x minus 2 to the 4th power, because that is the GCF as far as the 3x minus 2 factor goes. Next, I'm going to do it with the second factor. So 2x plus 7, 2x plus 7. What does that give me? Well, let's see, the smaller exponent is 2, so I'm going to divide out, or in a sense, factor out a GCF of 2x plus 7 to the second power. 2x plus 7 to the second power. And of course I'm going to write it down here as well. 2x plus 7 to the second power. What have I done now? Well, I've done nothing up here, but I've pulled out two parts of the GCF. I know that those are two factors that will be a part of my final complete factorization. Up here though, what do I got? Let's change colors. And again, if you're wondering why all of a sudden I put this black background, it's because I used to read Goosebumps books and read all the Goosebumps websites when the internet was still kind of new and exciting, and so I always liked the lime green on black, so deal with it. Let's see, so what do I got? Well, 3x minus 2 to the 4th over 3x minus 2 to the 4th, that whole thing cancels. And likewise, 2x plus 7 to the 2nd over 2x plus 7 to the 2nd cancels as well. So those whole pieces are gone from this expression. What's left though? Well, let's see. Something to the 3rd over something to the 2nd. Exponent rules say that that one will cancel and we subtract the exponents, which will make this power 1. You're going to see powers equal to 1 a lot when you do these problems. Pretty much twice every time. Over here, something to the 5th over something to the 4th. Same thing happens. We end up with, that's a weird looking one, we end up with 3x minus 2 to the 1st power. So what do we have? Well, basically we're trying to figure out what goes here. What's the rest of this factorization? We've gotten rid of a bunch of big pieces. We have left 2x plus 7 to the 1st power. We have left 3x minus 2 to the 1st power. And we have these coefficients, 6 and 15. And of course everything's being added. So we have 15, 2x plus 7, plus 6, 3x minus 2. Now some of you might be thinking that at different times I've told you to pull out a GCF. I'm going to just leave it there just so that way we don't end up with having to rewrite anything down here. You'll see it works out okay. Okay, so what do we do? Well, this thing is one or two steps away from being done. All we need to do now is actually go ahead and combine like terms by distributing and then simplifying. So to do that, I'm going to switch to the lovely silver color. I'm going to distribute into 15 then. Distribute into 6. That's going to give me 30x plus 105. Again, you got a calculator. You can always check if you're not sure. Plus 18x minus 12. This is going to give me 38x, it appears. Did I do that correctly? Looks like it. Plus, no, sorry, this will be plus 93. I feel like something's a little bit off here. Let's see. Oh, what's off? Let's go back and do this again. I can't add. Okay, so what are we going to do? Well, now we've just got to basically distribute all this stuff out and then combine like terms of what we have. So what do we have? We have 15 times 2x plus 15 times 7. That's going to be 30x plus 105. Over here we got 6 times 3x is going to be 18x. 6 times negative 2 is going to be negative 12. That's going to give me 48x plus 93. So now at this point you would say, oh, let me just go write that down here. I'm just going to drag it over. No, don't do that yet. Just ask yourself, can this be factored at all? Is there a GCF maybe that's hanging around in here? And the answer is yes. In this case, we actually have a GCF of 3. If we pull out a GCF of 3, we'll be left with 16x plus 31. This is our final piece. So we write it down here and include it all, including that GCF, and we have completely factored this problem. So again, if I were to reiterate that in steps and like turn it into, say, a plan, what was it that we did? First, we basically drew the T, like we made it into a big T problem, so that we could organize our stuff. Again, most of these steps are just organization. So I guess if we're doing this as a plan, I shouldn't say drew, I should say draw. So first thing you do is you draw that T, that way you've separated everything else. Now you've got to GCF out smaller power. And of course this is an oversimplification. All we're doing is basically pulling out the factors that have the smaller exponent, because that's how GCFs work. We write them on the answer line, because again they're important parts, they're important factors. So we include them in our answer already. And step 4 is to basically rewrite it. Where I did that was right here. There's step 4 right in there. Everything else is step 1, 2, 3 up there. Step 5 will do two things. We're going to distribute and CLT. So distribute in, blip, 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 and then combine like terms, which we did right there. So this is step 5 basically. And then step 6 is basically to check for a last GCF, just in case there's one there. In this case we had one, so this was step 6. Then last is all on the line. So basically put that last factor or factors or whatever the case may be on that line, and we're good to go. So there is one full problem for you. Let's do another one, but let's make it a hard one. And okay, here we go. We're going to go through a really tough one. This is as tough and as difficult as it gets. Why? Because there's fractions all over the place. There's fractions everywhere here. We got fractions here and here. There's a fraction here and here. There's a fraction here. There's a fraction here. And hey, look, is that a flying fraction over there? Yes, it does appear to be a flying fraction. There are even flying fractions here. So lots going on. But in fact, our strategy is going to be pretty much exactly the same. The only difference is going to be when we actually get to the point where we have to deal with these fractional coefficients in front. So what do? Well, we start off by drawing my little t. I used to call these the factoring superstar problems, because if you can factor them, you are a factoring superstar. The actual contract value for being a factoring superstar, not very high. It's the same as being a student, which is 0. But that's okay, like that's beside the point. So here we go. What are we looking for? We're looking for each factor, and we're looking to see which one has a smaller exponent, so we can factor it out. So I've got 5x plus 1 to the negative 3 over 4. I've got 5x plus 1 to the 1, 4. Which one's smaller? Obviously, that would be 5x plus 1 to the negative 3 over 4. Why is that smaller? Well, it's negative. The other one's positive. It's got to be smaller. So we're going to divide that out. Or, technically speaking, what we're going to do is we're going to factor out that GCF. So I can go ahead and include it right down here. 5x plus 1 to the negative 3 over 4 power. I've got one piece taken care of. Next one, you try it. Oh wait, if you try it, then I won't be able to do it because you'll be watching this later. So how about I do it and then you try it, or else you pause the video or something. So what do we got? We've got x plus 4 to the negative 2/3. We've got x plus 4 to the negative 5/3. Ooh, which one's smaller? The one with more thirds. So we're going to go ahead and factor out as a GCF that x plus 4 to the negative 5/3. In each case, we're going to write it, and we'll write it down here on the answer line so that we got it taken care of. X plus 4 to the negative 5/3. So now, what's next? Next we start to do our little chop-in work. So I'll do orange this time, what the heck. So what am I going to do? I'm just going to chop anything that cancels. Bam, and bam. Those guys are gone. What I'm left with then are some exponent stuff. And you might go, oh geez, this is horrible. I've got x fractions, oh, what do I do? Well, in fact, one thing you could do is just basically pretend they're not there and just know that it's going to go to 1. Like, it always works out nicely that way. The other thing is you can actually verify with the exponent rules that this works. Negative 2/3 minus a negative 5/3 is negative 2/3 plus 5/3. That's going to be 3/3. That means that we now have positive 1 as our exponent up here. On the other side, 1/4 minus a negative 3/4. Imagine that. Minus 1/4 minus a negative 3/4. That becomes 1/4 plus 3/4. That's the same as 4/4, which means this is also equal to positive 1. That guy's gone. Why is that helpful? Well, now we're down to that next step. We're ready to start distributing in and doing stuff. 5/4 times x plus 4. Oops, getting ahead of myself here. X plus 4 to the 1. Well, we don't even need the 1. Minus 2/3. 5x plus 1 to the 1 power. And so there we go. This is our last factor. This is almost the end. This is like the second to last chapter of the problem. Now, unfortunately, there is a difficulty here. You might be thinking, hey, wait, this isn't easy anymore. I'm not sure what to do. What am I supposed to do with these fractions? Well, in reality, you could deal with these fractions by just ignoring them and getting the problem wrong. I mean, getting the problem wrong is always a possibility for any of us in any situation. But in fact, what I think is easier is I go through and I say find a common denominator. And the reason I do this is that if they have a common denominator, I can basically factor out that common denominator itself as 1 over that common denominator. Then I can pull that, set it out in front, and do everything else just like I did before. Just have to be really careful. So in this case, what would be a common denominator? Well, the x plus 4 and the 5x plus 1, those guys aren't going to change at all. The minus sign in the middle of them ain't going to change at all. But this guy is. 5 over 4, if I multiply up and down by 3, I'm going to get 15 over 12. If I multiply up and down by 4, I'm going to get 8 over 12. Now, how did I help myself? Not much, but bear with me. What I can do now is I can basically factor out a GCF of 1 over 12. How do I do that? Well, basically I've got 15 times this over 12 minus 8 times this over 12. I'm going to factor out a GCF of 1 over 12. And just throw that right down there. That way it's out of my way and I've got it. What does that leave me with? Well, switching to a white pen so I can show you now. I'm going to have 15 x plus 4 minus 8 times 5x plus 1. And then I'm pretty much there. All I need to do is now finish out the problem. So again, what did I do? I found a common denominator to make those fractions look alike. Then I factored out a GCF of 1 over that piece, which was 1 over 12. So last piece, what I gotta do? Distribute and combine like terms, and then hope that I didn't screw this up because my calculator's not good at helping me. 15x plus 60 minus 40x minus 8. This is going to give me negative 25x plus, it appears to be 52. So that looks fairly reasonable. I hope. Hopefully. Hope. And so what am I going to do? Well, basically, I don't like that version. I'm going to pull out a negative 1. There's no other GCF, but I just don't like having a negative there. So I'm going to write this as 25x minus 52. And then that will be my last piece. I'll include the negative sign right there, and 25x minus 52. And then that should be my final answer. I have now factored this problem completely. I figured out what numbers were left, and I've called it a day. And after consulting my calculator, making sure I had everything else right, it turns out that this is absolutely 100% the correct answer. I had put the wrong thing in my calculator when I was going through checking it, so it wasn't giving me the answer I wanted, but in fact this is correct. So to reiterate what we did, what was it that we did here that was so special? Basically, we started by doing nothing different. We factored out the GCF by finding the smaller power, just like we did before, canceled some stuff, found some other factors, the binomial ones, up to the 1 power. Then we had these fractions. To deal with these fractions, we found a common denominator. We basically made them so they're both over 12, and then we factored out a GCF of 1/12, so that we no longer had the fractions. Then to finish this guy off, distributed everything in, combined like terms, and then just because we had negative 25x plus 52, that's not pretty looking, factored out a negative sign, wrote it as 25x minus 52, and then we just included that negative sign there and included our last factor. That is our final answer, negative 1/12, 25x minus 52, x plus 4 to the negative 5/3, 5x plus 1 to the negative 3/4, and we're done. Could we write this a little differently and shove some stuff in the denominator because of these negative exponents? Absolutely, but why would you want to do extra work? Leave it this way, be happy. With that said then, this has been a review of Standard Quiz question number 5. Hopefully you never get it wrong, ever again. And until that point, either way, this is Mr. Steele signing off for the day, calling it a weekend on making of the Standard Quiz videos. Have a good day.